In math, it's important to be able to express numbers in terms of multiplication and also algebraic expressions in terms of multiplication. When we talk about multiplication, we're talking about factors. Okay, the pieces that make up the multiplication we call them factors. One of the ways that we learned how to show multiplication in elementary school was to show them into groups, or what we call arrays. So we can show 3 groups of 4 pennies by showing 4 pennies as one group, another set of 4, and a third set of 4. So we can express these 12 pennies in 3 rows of 4. So here we have 3 groups of 4, or 3 times 4. This can also be seen as 4 groups of 3. So we can show them this way as well, showing the reversibility of the multiplication. Okay, so 4 groups of 3 gives us the 12, or we can show the same 12 pennies as 3 groups of 4. And so this rectangular array is one way we can express multiplication. And the number along each side represents the factors, or the multipliers, or the groups. So the model that we're going to use for multiplication is going to be the area model. And this area model allows us to do simple calculation of math calculation, or we can use this for more complex algebraic expressions. And so this area model is very important. It's really important to understand how this area model works. The area model basically is that we have length times width equals area. So the length and width along the edges represent factors, or the multipliers, and the area inside, or the space inside, is the answer to that multiplication. So looking at this picture here, this is our area model. We have a length, we have another length here, and we have the area inside. And if we have the area of 24, we can ask the question, what times 3 centimeters? So this length times this length, so what times 3 centimeters is going to give us the area of 24 centimeter squares? And the answer to that would be 8 centimeters. So based on this area, we can come up with different multiplication facts, or division facts in this case. So if we want a division fact for this picture, we can say that 24 divided by one of the side lengths, in this case 3, would be equal to the other side length of 8. We could also show that 24 divided by the side length of 8 is going to give us the other side length of 3. So when we talk about division, we're saying that area divided by one of the side lengths gives us the other side length. When we talk about multiplication, we're saying that length times width, the 2 side lengths, gives us the number of squares, or the space inside. To come up with a third division fact, we'd have to use different factors. So we have to think of other numbers that multiply to 24. So we can come up with a third one by saying 24 divided by a side length of 4 would give us the other side length as 6. So again, based on this picture, we can express this 3 multiplication facts. Well, we can say that 3 times 8 equals the area of 24, or 3 groups of 3 groups of 8 equal 24. We can say that 8 times 3 equals 24, or 8 groups of 3 equals 24. Okay, so this is what we call the commutative property, where we can just switch around the multiplication. And to come up with a third, we would have to say that we have to come up with 2 different factors. So we can use the same ones we used up here. So we can say that 4 groups of 6 is equal to 24. And again, these are when we break up the number in terms of times, we're talking about factors. And we can come up with factor pairs. Okay, so we can say that 1 times 24 represents a factor pair. We can say that 2 times 12 represents a factor pair. We can say that 3 times 6 represents a factor pair, 3 times 8 represents a factor pair, and we can say that 4 times 6 represents a factor pair, and we can switch around those as much as we want. So this idea of this area model is very important because we're going to use this picture to help us understand more complicated multiplication facts, especially when we come to algebraic expressions. And again, it's important to know that multiplication and division are opposites of each other. They use the same picture. Okay, this picture expresses division as well as multiplication. And so if this picture is our model and has the multiplication and division have the same properties, they must have the same rules. Okay, so the rules that apply for multiplication must necessarily apply for division because we're using the same picture. They work in the same way. They're just opposites of each other.